So hi everyone, welcome back to another episode of the Codersarts. So in today's video, or maybe this is a project showcasing video series. So in this video, we are going to showcasing projects and also problem statement of the projects and what are the technical aspect of the project and how we have implemented and what are the different libraries and we have implemented. Also, we will get some idea like how the complete flow of such projects work. Even this project is going to give some more technical aspect as well, and also going to give you code walkthrough how the what are the use case of this type of projects and how we can similar type of how we can build similar type of project. Okay, so today one of our team member Pratibha, so she will explain what are the projects about and technical aspect, and also we will discuss code walkthrough and even what are the output of this project and how this project going to helpful for someone else, either maybe a student, developer, or maybe you are just company and you want to implement these features in your project. Okay, so now I'm inviting Pratibha, so she will now explain everything about this project. Okay, so hi Pratibha. Now if you present your screen, then you can talk about the projects. Either is fine.
So, hello everyone. Let me share my screen. Is it visible?
Yeah, I think just a second. It's
Okay.
yeah, it's visible.
Okay. So, the aim of this project is to classify the images of cats and dogs by making use of deep learning model. And in deep learning models, particularly, we'll be using the CNN architecture for this purpose. So, this is the problem statement. So first, let's just look at the data set that we have. We have quite a few images. You can see here for training. So there are images for cats, and then if we scroll down further, we'll see that we have images of dogs as well. Okay, so this is our data set. I think it will take long to get to that part where dogs are. So let's just check out one of the images here. So this is the image of a cat, and the data set is named like this, like a cat and the number of the image. Okay, so this is the naming that is being followed here. And the same.
Just a second, hold a second. So, is there any dimension of images required, like image size?
Okay, so basically, right now, when we'll go to the code, we'll see that the dimension of these images are not uniform at present in the training data. Okay, so later on, we'll make it uniform, but right now, they are like random.
Okay, got it.
Yeah. So the same way, we have the test data set as well. And here also, we have a few images, but you can see here that now the name, or I should say the label, is not present in here. Only the number is there. Okay, so you can see that some of the images are of cats and some are of dogs. So it's mixed here. So because it is the test data, so obviously there is going to be no label in here. So this is what the data set has been given for this purpose. Now we'll move to the code. Yeah. So first of all, because we are working with Google Colab, we have to mount a drive so that we can access these folders in which our data is set. Okay. So first we just mount the drive. Then we are importing some necessary libraries that will be useful. For example, we have imported pandas here, you can see, and then matplotlib for visualization. And then there is train test split to split the data set into train and test sets. We already have the data in train and test, but we want to make a development set as well, like validation set. So for that, we'll be making use of this early on, like later on in the project. Okay, and after that, we are going to use the Keras framework here. So we'll be like we have imported TensorFlow framework, and then using that framework, we are calling the Keras models that we'll be using later on in the project. Okay. So these are the necessary libraries that we need to import before we start with the project. These libraries are like opening the gateways of some functionalities that will be accessible to us. so that we don't have to write the code for a few things. For example, we can just directly use the train test split function. We don't have to write the code for it ourselves explicitly. So this reduces our work by a great deal, and
Mhm.
so on and so forth. The same thing goes on with the activation layers and the flatten function that we are going to use, batch normalization and all. Because if, let's say, we have to code it from scratch, then it will take a longer time, and it's frankly like, no, like, it's not normal. Like, normal people, even developers, that all of them cannot write such codes. So that is why importing necessary libraries is a very important step, because it bridges that knowledge gap. So even if you don't understand what is going on behind in the algorithm for batch normalization, but you know, okay, like, if I'm going to implement it, then this will be the result of that. So only knowing that much is enough. Okay.
Okay.
So this is the first step, that is importing necessary libraries. Then here we are just checking the number of GPUs that are available. So here we can see that we have one GPU available uh, in our runtime. So that would help us to train a model faster, GPUs. Okay, so that is why we are going to make use of GPU in here, in this environment. Now,
Mhm.
apart from that, like, next step is setting up the directories. Although we have mounted a Google Drive here, but we are currently not in that particular folder where these data files are present. Okay, so for that we are defining the path first. So as you can see, this is the project directory for this folder, particular folder, cats versus dogs. So this is what we are passing in to this variable called project directory, and then we are changing the directory to this folder. After running this cell, we are, you can say, that present in this cell, okay, in this particular folder of Google Drive. So now the notebook here is pointing to that particular folder, and here we are running the code, which is to be run only once, because we are just extracting the data from these zip files. So you can, as you can see here, that we have two zip files,
Mhm.
and this image data set was present in these files at first. Okay, so in order to work with images, then it becomes very necessary to extract these zip files first. So this is the next step, where we are extracting the data from these zip files. You can see here that here we are extracting data from the train zip, and then later on we do the same with the test zip as well. Okay,
Okay.
so this, here we are run the data, and you can see now that we are going into the train folder. Okay, so once the zip file has been extracted, you can see that in this folder we have two new folders, train and test, like, after extracting these two files.
Mhm.
And now we want to see like, what is the content of these folders after extracting. So that's what we are doing here. We are just printing the name of the first 10 files in that particular folder, and you can see here that we have define the train folder. Now then we are just listing the directory, that is listing the names of all the files that are present in that particular folder, like the train folder. So here we see the name of these files, that is cat, and then the number of image that is there. So like, it gives kind of a validation that, okay, it is pointing to the right folder,
Mhm.
and the data is present in there, like, it is reading the data in there. Okay,
Okay. Mhm.
yeah. So after that, just extracting these images is not enough in order to train the model, because it is a supervised learning, supervised algorithm that we are going to use. Like, classification is a supervised algorithm, so along with the data we need a label as well. So as we saw in our data, when we went in this folder, that the label is present in the file name itself, right? So like, cat is present, stating that this image is of the cat. Okay, and similar, like, the same thing is happening with the dog images as well, that instead of cat, dog would be mentioned in here. So we are collecting now the name of labels, or the classes, we can say. Okay, so we are just going to split it here. As you can see that we are splitting it on a full stop, because you can see that these labels are separated by the full stops here, right? So that is what we are doing. We are just splitting this name on full stop, and then just extracting the first word that is extracted. As you can see that here we are indexing 0. So here we are printing the first 10 classes that has been extracted from the names, and you can see that all of them are cat, because in the folder itself, first we have cat images and then we have dog images. Okay, so this again validates that okay, the results are in accordance with the data that we have. So now we have collected the name of the files and their labels. So the next step is to create a data frame. Okay, so the name of the file and its label is present now, and now we will be able to access these files. Just by creating this data frame here, we have just collected and stored the information in one particular spot. Now, whenever we want to access the data or visualize it, we can just first go to this particular data frame, and then from here we can read the file and its corresponding class. So now the corresponding class, or I should say label, is present along with the name of the file. And here we are just calculating the number of each image that is present for cat and dog. So you can see that there is no imbalance in the data set. Here we have also visualized it. Okay, that 12,500 images are present in the train set for cat and dogs respectively.
Okay.
So in this case, as I said that the class distribution is same, so there would not be any bias in the model because of any kind of imbalance. Okay, so that again is a great thing. So it reduces our work. Otherwise we would first have to
Mm,
remove the imbalance if there was any in the
mm,
project. Okay,
mm,
after that, here we are just displaying, like visualizing our train data along with its label. So
mm,
here you can see that earlier in the folder, like you would have to scroll very long to see the images of the dogs, but here
mm,
we are just randomly choosing any of the 8 images here. Okay, so each time you'll run this cell, the images would not be the same. Like there are going to be 8 images in here, but these same images won't be present, or I cannot even say that only 2 dog images will be, or 3 dog images will be in there in the next run. It may be so that all of them would be cats or dogs. So it's just going to be random selection. So after that, like once we have visualized this data set and like collected the data set and visualized the data set so far, now what we need to do is we need to process the data so that it becomes a suitable input to the architecture, to our model. So that is the next step after extracting the data, that is data pre-processing. So here now we are setting the size of the images. Again here, let me just make it clear that in visualizing the data like this, what we can see is that the shape of the images is not uniform. You can see that this is more rectangular, this is more like a square, right? So just by visualizing, we can see that okay, there is no uniformity in the size of the images in here. So that also will become a case of concern, because the model would require a uniform set of images, like the size of images. Okay, so for that, here we are just setting the desired width and height, that is 128. Okay, so like our images that we are going to feed to the model are going to be in the shape of squares, because the width and the height are going to be the same. Okay,
So, okay,
and
so
then
just a second.
here,
So, how we selecting like 128? So, is this some standard or recommended by
yeah, this
algorithm?
is a standard value. We choose 128 or 256 or 150.
Mm,
Usually, these values we choose, but it's arbitrary. You can choose it on your own. It just depends. Like if you are choosing a larger size, then the model take longer to train. Okay,
mm,
so just to reduce our burden, we are just going to take 128 cross 128, and then again, this choice depends on the data set itself as well. Let's say the smallest size that is present in the this data set is let's say 130. Okay. So in any of the dimensions, like either in width or in height. And then if you want to select an arbitrary choice of 150 cross 150, then it won't be possible, because either the width or height of that particular image in the data is already 130. So you cannot select 150 out of it, right? So in that case, there will be an error. So depending on the data set also, this choice is set. So because we already saw that the dimension was not that big in the train set, so
mm,
we have just chosen here 128 cross 128. You
mm,
can choose any values that are less than this or less than the smallest dimension of any of the sites, like width or height present in the data set. Okay, so that is how we choose the dimensions.
okay.
Then so here we are just setting the variables with these values, but we are going to use it later on. Okay, so now here we are making use of the train test split, right? So here we are just splitting this data here, this data frame. We are only reading the data from the train folder, right? So because up till now here, what we have done is we have extracted the data from train zip, and then we just read all the name of the files and extracted the labels from the train folder here, from this particular folder. Okay, so currently the test is not present in any scenario in the code so far, and that is also the norm, because at the time of training it is suitable that test data should not be introduced to the model at all at any point in training. Okay, so it's
Mm,
better to not to deal with testing data until and unless your model has been trained. So what we are going to do is we here are making use of the train test split to divide the data frame into two parts, basically in the ratio of 80 to 20. And we are creating a train and validation set out of it, because we already have a test set. So we are creating a validation set in here that will validate the results of our model while training. We'll see that later on. Okay, so by running this code, what is happening is we are dividing the data into two sets of 80% and 20% of the original data. And the set that is going to contain the 80% of the data randomly, that is the selection is also going to be randomly in here. Okay, so the 80% would be given to the train, like the data set, 80% of the data set would be the train, and the remaining 20% would be the validation in here. So we can see here that 12,500 is now divided here into, okay, not 12,500, that was for cats and dogs. So like the double the amount, right? So here we can see that the train is now 20,000 and validation is now going to have 5,000 images in it. Okay, so randomly the dogs and cats are going to be in there. As we can see here, we have some dog images and cat images. So this is a random assignment in here. So far we have divided our data into a train and validation set. Now we are creating some data generators here. Okay, so this generator would augment the data and then pass it to the model at the time of training. Okay, in batches that we are defining here, like batch of 32 images at once. Okay, so here we can see that we are setting the train data generators for validation and train, and it is quite different for each of these. Okay, let's see for train first. Like here we are passing in some arguments, that is rotation range. That is while augmenting the data. Augmenting the data means that we are just going to slightly make a different data out of the current one. For example, let's say we have this cat image, and it is currently in this format. So for example, you can see here in this image
mm,
that this is the cat image. Okay, now using just this image, we can add some slight variation into the data. For example, we can rotate this cat by 20 degree, or by like any degree between the range of 20. Okay,
mm, mm,
so if you just slightly tilt it, so it can be considered as a different data, because the position of the pixels would be different in the image by then. Okay,
mm,
similarly here we are going to rescaling. Rescaling is a standard operation, so let's not talk about it. But then here we can see some functions like shear and zoom. For example, let's say we'll just zoom it out. For example, we are just cropping and just stretching the image to 128 cross 128 size.
mm,
So now the body of the cat would not be visible, only the face would be visible. So all these kind of zoom in the range of 20%, and shear range also 0.1. So these are the different types of functions that we can apply on the image to make it slightly different from the original.
Yes.
For example,
Mm.
horizontal flip is also there, so it will randomly, like the generator while passing on the data at the time of training, would just randomly flip the image here horizontally. For example, the right would become left and left would become right. So that also, you cannot say that these two images are same, because if we look at the level of pixels, then the value has been swapped, right, from left to right. So that also brings in difference. Then fill mode is also there for those cases where, the image is small, and then you are trying to like you are adding some rotation in here. So let's say it is rotated by 20 degrees, but then there was some gap. So how are you going to fill that gap? So fill mode is for filling those kind of gaps in the image in the particular described size. So here it will just reflect the pixels which are at the boundary of that value where the image is not present, like the pixels are were not there after shifting the
Mm.
image.
Yes, yes.
Okay, so that is how it compensates for those kind of things. So here we are just passing in the reflect. There are other functions as well in here. And then this is the width shift and height shift range, like by 10% the width and height would be shifted. Okay, so then again fill mode is going to be used in there. And then let's come to the rescale, because that is being implemented here in validation as well. So rescaling is just normalizing the image pixels, okay, the array of the image that is going to be there. So now we come to this rescale part here, because it is all
Mm.
also present in the validation generator.
Mm.
So here, we what we are doing is we are just normalizing the pixel of the images, because the pixel ranges in the array that is representing the image varies from values from 1 to 255 based on the channels. Okay, and the like intensity of the pixels which are there in the image. So we just want to bring them to uh, like equal scale for all of the images that are there. So it's
Mm.
just like scaling the data, like the way we scale the data in a normal machine learning workflow. So the same thing happens with the images as well. So in order to normalize the images, we just divide it by 120, 1 divided by 255. 255 is because the value of the pixels ranges from 0 to 256.
Mm.
So because these are the values, so total values, let's say they are 255, range 256 is not included. Okay, so that is why we are dividing by 255 to bring them into a scale of zeros and ones only. So and here in the validation data generator, we are only applying the normalization, and no other thing like this is being implemented. That is because, let me tell you that at the time of training, when you are passing in the train data and the validation data, so we want the validation data to remain the same as it is in the original data set here. So we are not going to augment it. Only at the time of training, in the train set that is going to be passed, we are implementing all these augmentations, because we want a model to learn more features. Okay, so as much as possible. So that is why it is being implemented in train but not in validation.
Mm.
So after this here, this was the image data generator function that we are setting here. But by making use of this function and the data frame that we have created here, like the train and validation, this is the train generator and validation generator that is we are going to pass into the model actually. So
Mm.
here what it is going to do is, by calling this train data generator function, which is going to implement all these things, we are extracting the name of the files from the data frame. Okay, so there are different functions for this. Like here, we are making use of the flow from data frame, but there is flow from directory as well, so that you can directly pass in the name of the directory, like the path of the directory instead of the data frame. But here we are choosing data frame. So let's say here in train, we have this kind of format in the data frame, like the file name and the class. So that is what we are passing in here as well. The X column is the file name and Y column is the class, and the target size is the size of the image that we want into pass. Okay, so now here we are making use of these values that we set here earlier, like
Mm.
128 cross 128. So this is the size here,
Okay. Okay.
as we
Fine.
have defined here. Okay, so now we are making sure that the size of the images that are going to be passed to the model is going to be 128 cross 128. And here this class mode parameter that has been set to categorical is going to one hot encode the class column. Okay, so the dog and cat, as because we cannot directly pass in normal English words as a label. Look, we can, but encoding is better because models like they want they expect the not expect, but they work well with binaries. Okay, so zeros and ones, so that is much better for them to understand. So that is why we like do one hot encoding or any kind of encoding, because that is more suitable for the models at the time of training. So because models cannot understand plain English, but they can understand ones and zeros. And then this is the batch size, the batch in which the data set will be like forwarded to the model, that is 32. So at in one epoch, at one iteration, only 32 training images would be sent to the model, and the validation images as well. So here, this is the train generator and validation generator. Same thing is happening with the validation generator here. It's just that the name of the data frame is different. That is corresponding to the validation set. After that, here also, like it just states the same, that 20,000 images were there in train and 5,000 were there in validation. Okay, after running the cell. So next is the model architecture here. So here we are making use of the CNN architectures. As you can see that we have several layers, 1, 2, 3, 4 CNN layers, and after that there is one fully connected dense layer. And then we just like set all the learning rate and parameters. So let's look at the code also here. Just try to understand, like I'll just discuss one layer and the others are practically the same. So here, this is our first layer, that is the input block. In here we are passing the input shape as well, but in the others we are not. That is why this block is being called as the input block. So we start with the CNN layer. Here we are defining the number of filters which are to be there. So let's just quickly talk about CNNs. So CNNs are convolution layers, and the name suggests, like the name is self-explanatory, but let's say we have this image here. Okay, consider this image, and the model wants to learn some features from this image. So what it's going to do is, it is going to like the number of filters that we are going to set, those number of filters are going to be applied on this image, and they will convolve over it, like they will move from here to here, like all around the image, extracting the features from it. So that is why the name like that is why this layer is called the convolution layer, because the filters are convolving over the image and collecting the data from it, that is the feature, and then generating the feature map after each layer. Okay, so in this here we have said that the filters should be 32. So 32 filters would be roaming around all over the image, collecting the features. And the size of the kernels or the convolutions that are going to be performed is 3 cross 3. So you can see that if this image is 128 cross 128, then a filter of 3 cross 3 would be running all over it. Okay, and not just one filter, there are going to be several. For example, here in the first layer we have set the number of filters to be 32. So exactly 32 filters would be doing the same job. Okay, and their size would be 3 cross 3. And this is the activation function, that is ReLU. So ReLU is rectified linear activation function. So what it does is, like the values that are going to be calculated from this convolution layer, it won't let them go to zero. Okay, so that is the use of the ReLU activation function here. After that, we are just setting the input shape. So it is going to be 128 cross 128, and the image is going to have 3 channels here. We have already set the channels as well. 3 channels represents that the image is going to be having three channels, namely RGB, that it is a colored image. Okay, so this is the convolution layer. Then we are applying the batch normalization layer in here. And batch normalization is like all the activations that it is going to calculate from this model, it is going to normalize it. Okay, so that it reduces the burden on the next layer and it stabilizes the model. Okay, and then after the batch normalization, we are implementing the max pooling layer in here. So max pooling, again, this layer is going to reduce the spatial dimension of the model. Okay, so again, the let's say the feature map, it will just reduce the size of the feature map. It, like, let's say for example 2 cross 2 we are passing in the pool size. So from the feature map, the region of 2 cross 2 is going to be selected, and from that region the max value is going to be passed on, like collected from each of the filters. Okay, like the feature from the feature map, and then we pass it to the next model. And here, before that, we are implementing the dropout layer as well. The dropout layer here is again doing the same kind of thing as batch normalization. We can say that batch normalization and dropout layer are regularization layers that helps to stabilize the model and prevent overfitting. So dropout here suggests here that a 0.2 represents 20% neurons are going to be randomly deleted from the network. Okay, so that is the use of dropout. So the same kind of layer we are implementing here also. The pooling size remains the same. Dropout also is remaining the same. It's just that the number of filters have increased in here. The size is also the same, and the same thing is happening in the third layer as well. The number of filters is now 128, and then again we are normalizing the outputs of this layer and then pooling it, okay, to reduce the spatial dimension, and then just forgetting randomly the 20% neurons from it. After that, like after the CNN layers, here we have fully connected layer. Here we are flattening the output of the convolution layer, because here it is in the size of image but flat. Like the dense layer wants the input to be in 1D. So here we are, the flatten function is going to be used for that purpose. It is going to convert the output from this layer into a 1D vector, which is going to be passed as an input in this particular layer, the dense layer. Then after that, the same thing, batch normalization and dropout is happening. And then this is the output layer in which we have implemented the softmax activation that is particularly used for the cases where we are training a classification model and the output is going to be binary. So that is why the value is 2. Like either it's going to be cat or a dog. So here, this is the summary of the model. As you can see, the total parameters here are 51 lakhs 12,000 and 514. So these are the total parameters, out of which this many parameters are trainable, and only these parameters are non-trainable. Okay. After that, here, like once the model architecture has been set, so okay, and also this is like not a fixed type of architecture. You can increase or decrease the number of CNN layers according to your liking. Okay, so this is the place where you can like play around with the architecture of the model to see the performance. Okay, so this is also one of the way by which you can hypertune your model, by just changing the architecture, removing some layer or adding more layer to it. If you will add more layer, then the model would become more deeper, and it is generally expected to perform better. But it takes that much time as well, because the trainable parameters would increase. Okay, after that, here we are just setting some callbacks. So this is the learning rate. So for this, we are using the reduce LR on plateau function. So what it's going to do is, like, if the validation accuracy does not improve into successive iterations, then it will decrease it, okay, by multiplying it to a factor of 0.5, and the minimum value of the like learning rate would be this that has been set. And verbose one here represents that whenever this kind of condition happens while training, it will print that okay, now the learning rate has been decreased. Okay,
Mm.
so this is the learning rate, the rate at which the model is going to learn. And this is a callback to stop the training in case the validation loss does not improve after 3 iterations. So patience basically represents the number of iterations to which it will wait before making any move. So here also verbose has been set 0, so we won't be able to see it here at the time of training. Then we just compile the model, pass in the optimizer. We have used Adam here. We can also use SGD or RMS prop in this case, and the loss is binary cross entropy because in this case our model is a binary classifier.
Mm.
Okay, as we can see here. So in that case particularly we use binary cross entropy, and the metric on which we are going to evaluate the performance of the model is accuracy. So once we run the model here, you can see that we are passing in the train and validation data using the train generator and validation generator that we like that we have set above in the
Mm.
project earlier.
Mm.
Okay, and these are the callbacks that we are passing, that is the early stopping and the learning rate that we have set here. And then we just start training the model once this like this cell is running, and you can see here that here the like learning rate reduced. Okay, and I think there is one more case here. So this is what verbose do. Like if we had not set the verbose to 1, then this message would not have been printed in here. Okay,
Okay.
so we see
Mm.
that after training, um, a model has reached an validation accuracy of 93%, and the accuracy of the model is 92%. Okay, so there is a little bit of overfitting, but it's fine for this project. This particular project, it was fine. So we did not hypertune it.
Mm.
Okay, so now after that, we are just saving the model. It becomes important if you don't want to keep retraining your model each time. So now what happens is, like if I've saved the model, then I don't need to run this cell each time I want to like classify any image into cats and dogs. Okay, I can just simply load this again and then just pass in the test data, and that's it. So once it has been trained and saved, then it reduces a lot of burden, like of running the model again and again,
Mm.
for those people who don't have access to GPU and they want to maintain their GPU time on Google Colab. So it's a best practice to like save your model. Okay, after that, here we are just plotting the learning curves. Okay, so we are plotting the accuracy and the loss. It's just for the purpose of visualization. You can also see it from here as well. So now we come to the testing part. So now after the model has been trained, we come to the test data. So now we are going to deal with it in the same way that we dealt with the training data. Okay, so we are again going to extract the file here. This
Mm.
is the zip file. This zip file, this code is going to extract the data from this zip. And once it has been extracted, we'll have a folder like this. Okay, in which only as I showed earlier, that label is not present. It's just that the number of the images are going to be there. So that is what we are reading, the file names that are present in the test data directory, and we are setting the class ourselves. That is, all the images that has been read, we are setting its class as unknown, because at present we don't know it. And then what we are doing is, again we are following the same structure. We have created a data frame, but now we don't need to split it because it is already a test data, right?
Mm.
So it's not like we need to validate anything now. So then again, here this is the count of all the values that are present in the test. So we can say that in the test folder we have 12,500 images randomly of cats and dogs. And then we are again setting the data generator for test as well. Okay, and in test also we are not you get please pay attention here that we are not doing any kind of augmentation,
Mm.
because it is not needed. We just want to simply know whether this image is of a dog or a cat. So there is no need for augmentation here. So people should avoid like adding all those function in test generator. Then again, we are just calling in the data from here. Class is like, it doesn't matter at the moment because we don't know, but still we have to pass it. That is why we set it as unknown. And the batch size and target size, everything is going to remain the same, and shuffling is also going to be false because we want to correspond the results
Mhm.
to the actual image. Okay. So all this, what I'm trying to say is that whatever you are implementing on your train data, the same thing, in the same way, you need to pass in your test data also to the model. So it's just that here we are not choosing to augment the data because it is not necessary, but we do need to create a image data generator for test as well to pass to the model because it is expecting the data to be in that format. Now here we are just yeah, using the model that we have. We are just passing the test generator to it, and verbose has been set to 0, so it's not printing that kind of summary of training. Okay. So after running this cell, what we receive is the prediction probability and not the exact prediction. So it's not going to be a yes or no kind of thing because it is a binary um, classification task. So we expect the output to be either 0 or 1, but it's going to be in the form of an array,
Mhm.
this particular result. So what we do is we make use of the np.argmax function to find the index of the place which is having the most probability. For example, there are going to be two places in one row, two columns, one representing class and one representing dog. So like whichever one of them is having the highest probability will be
Mhm.
as selected as the chosen class of the image.
Mhm.
So that is what we are extracting here in predictions, and then we are just mapping the values that cat has been like 0 has been mapped to cat and 1 has been mapped to dog, and this is the resulting solution. Like the first image is going to be like has been assigned the label of dog by the model, and this is the result. But in order to cross check, we need to visualize it.
Mhm.
So here we are running the code for visualization, and we are also like setting the label as well here along with the image, and we can see that mostly because the model has been trained up to like 92% 93% of accuracy, it
Mhm.
is mostly correct. You can see that it is classifying a cat as cat and on most accounts, although it's not like it's going to be 100% classifying the images into dog and cats, but
Mhm.
it is performing well for.
Mhm.
Okay.
Okay.
So this was the whole project, and it's not just that we can do it for cats and dogs. If we have the data, we can classify different species of flowers,
Mhm.
or we can even using c for 10 data set, we can classify different kind of things like planes
Mhm.
and animals and flowers together in a data. So it doesn't matter, it's just that it is a general workflow of any image classification model that has been trained using cnns.
Mhm.
Okay, and it's just like we can create our own architecture as well, like we have done it here, or we
Mhm.
can make use of pre-trained models as well. Like they also like are making use of cnn's only, but the
Mhm.
architecture is different and very large. So
Mhm.
for those kind of models, like pre-trained model can also be used. They also perform a greater accuracy, and the accuracy with pre-trained models would be more than this.
Mhm.
Okay.
Okay.
Yeah.
Mhm. So this is complete code walkthrough of this project, right?
Yeah. So this is how one can classify
Mm.
images.
Okay, okay. So let me go. So let's answer some of the questions. So like, what are the complexity of this project? So this is for to whom this type of project is helpful. Like from beginner or maybe experienced person, or maybe somebody want to specialize in deep learning. So what are the complexity of
Yeah,
project?
people who are interested in deep learning,
Mm.
for them it is okay. And apart from that, people who are like beginners but still like they are familiar with machine learning and all the
Mm.
terms and concepts. For example, what is prediction probability and
Mm.
all those stuff. So like if they have a basic understanding, then they can like learn up to this one as well, like they can make it
Mm.
happen. Yeah.
Yeah, so first they might be already have some, familiar with how the deep learning work and what are the different, obviously
Yes, yes.
you have used something like, okay. So if somebody, want to uh, learn about this project, so how implement this project from scratch, from end to
Yeah.
end, somebody want to learn, okay. So what will be the learning? So if somebody work on this project, so either they want to work on their own, or maybe they can hire us for, they can,
Yeah, they
uh,
can definitely see there are all kinds of people. Some
mm,
people would be able to just like read something and then implement it,
mm,
and some people would even watch videos
mm,
and like read up everything, but still they won't be able to understand it.
mm,
Okay, so those who can handle it on their own and they can just follow along from the code, then that's fine. But
mm,
yeah, people who need extra support can like come to Codersarts, because we also provide live
mm,
one-on-one sessions and self-paced courses as well, where we explain these kind of things,
mm,
right? Because
mm,
let's say this like implementation part is not that tough, but mostly where people fall short are like handling the
mm,
data processing part, and like augmentation and how you can make it work. Like most of the people who are like beginners won't be able to grasp that.
mm,
Okay, so that becomes one of the problems. Like they don't even get to come to this point of
mm,
model architecture because they are
mm,
not able to handle the data.
mm.
Okay,
Yeah, yeah,
so
yeah.
that is one of the complexities. And then after that, like let's say here, though we have implemented the architecture on ourselves, but if somebody is learning, then like based on their architecture, maybe they are making some mistakes, or maybe the model is not that deep, so the output may not come
Mm,
like as expected, and then they may feel discouraged and
mm,
leave it, because people do tend to leave it once they see that nothing is happening like that as expected. So
mm,
because they lack that kind of knowledge, or information, that okay, it's just that I need to change
mm,
some things, and
mm,
then maybe try again and then it will work. So all those kind of things
mm. Yeah.
can be a complexity, but these are general kind of things, right?
Mm,
So again, it depends from person to person. But
mm.
yeah, generally for deep learning, like as compared to machine learning, deep learning is quite complex and people do need help with it.
Mhm. Yeah. So most of the time, this type of project, like people face, like they they are not, going to like basically training the model, right? So they are not successfully able to train the model. Basically, if this type of
Yeah,
project, like you have already explained, like so first, formatting the data according to how the
yeah,
models
how it's
model
going to be
need.
put to the
Mm,
input. Yeah,
yeah.
I remember that initially when I used to, like I
Mm,
was a beginner, then at that time
mm,
I was not able to pass in the data to the
mm.
input
Yeah,
layer,
yeah,
because I
yeah, yeah.
always used to face some
Mhm.
error of input shape.
Mhm.
So understanding that is also very crucial, and people do get stuck here. Like even if they are able to,
Mhm.
do all the augmentations and everything,
Mhm.
even then it
Mm.
happens
And
sometimes.
and
So yeah,
also like how they can call, like you have already talking about CNN layer one, right? So maybe when
yeah,
you have to call, you have to call four times add method, right? So when we have to call, so I don't think, yeah. So obviously the sequence, in which sequence we have to call which one, right? Which parameter we have to pass.
Mhm.
So that is one. So I think two main challenging part, like uh, formatting the data, not formatting, giving the input according to how model is accepting
Yeah,
the input,
yes,
and
yes.
then how the calling different layers, and in each layer how we call different different parameter you are
Mhm.
talking about,
Yeah,
batch normalization or max
yes,
pool or anything else. So
yes,
the second
yes.
challenging is this one, and the same thing will repetitive, like training. Once the training is done, so in same format you have to test the model according the and
Yeah,
data will be the
yeah.
same form.
Yes.
Okay.
For example, let's say here
Hmm.
in first layer we have chosen the values, but the
Hmm.
next layers are dependent on the previous layer. So
Hmm.
all the values that we are going to set here should be in accordance with the previous layer. Otherwise,
Hmm.
people do face errors in those parts as well. So these
Hmm.
are some of the common errors, like the input shape, and
Hmm.
then the number of parameters that you are setting in here. Okay.
Hmm.
So all these kind of things
Hmm.
do
Okay,
pose
okay.
some problem.
Okay, fine. So first, Pratibha, answer like what are the different technology, like what the person will learn. So if somebody complete this project, so what are the skill set they will feel confidence, like after completing this project. So what are the different skill set, like you have already mentioned, like yeah, basic NumPy, pandas, these are basic one. But other than
Yeah.
that, TensorFlow, Keras. So how much this? So first explain what are the different technology we have used in this project, and somebody will learn from this. And even if you want to explain like, and what are the, like suppose you have used TensorFlow, right? So how much TensorFlow use? So if there is basic concept of TensorFlow using, or maybe covering many of the topic of the TensorFlow. So first brief
Okay.
about technological part. Okay.
Okay. So basically, here we have used pandas just for creating the data frame,
Hmm.
just for the purpose of referencing the images in the folders.
Hmm.
And then one thing that people would learn, the first thing would be to handle zip files using Python, extracting
Okay.
data from it,
Yeah.
and then reading the data from those folders. So this is
Hmm.
the first thing. Okay. And then after that, just handling the data and like transforming it into a form that is suitable to the model.
Hmm.
So that also is very crucial and one of the most important and time taking part,
Yeah.
because setting the architecture, even if let's say you are not setting your own architecture and just making use of any pre-trained model, even then only thing that you need to do really well is to transform your data.
Yeah.
So that is one thing that you will learn here in this case. So there are different ways you can pass in the data to the model. It's not always that you need to use data generators.
Hmm.
Okay. So there are different
Okay.
ways, but in this case you are learning to use a data generator, and you will see that here we did not load the entire data into our environment because we
Hmm.
have not read the images as arrays, right? We only just have the name and the class and nothing else. So it's not, we are not taking any extra load in the project in here.
Hmm.
So it's
Okay.
just that by making use of TensorFlow functions from flow from data frame, we are just referencing it here, and it is all being done in the backend. But at this time in the environment, the whole data set in the form of an array is not present. Okay,
Hmm.
otherwise processing it becomes a very time taking. But in this
Hmm.
case, it is like, I wouldn't say that it is not gonna take time, but it will be faster than that. Okay,
Hmm.
and it will save you time because then you don't have to code it like that in that manner if you are not using the train or
Hmm.
validation generators.
Hmm.
Okay, so that is the first thing. Visualization is also one thing that you are going to learn in this case, creating this kind of visualization where the corresponding image, like the along with the image, the corresponding label is also present in here. Okay, so people even find this very difficult, like all
Yeah.
those who are
Concatenating
beginners.
the. Hmm. Yes.
Yeah. So and then it's like for some people would just print out only the first 8 images each
Hmm.
time. So like randomizing it also, it's nothing really big. Okay, it's
Hmm.
nothing big as a point of view from a developer, but
Hmm.
for learners it can be a daunting task. And then as we discussed, like after we are done with the data, then just setting the architecture, like the input shape and all these things, like matching all these things can
Hmm.
be difficult. In here, we are making use of all these functions from Keras TensorFlow only. Okay, all these things you see that sequential is like we are adding the layers on top of each other. Okay,
Hmm.
so we are making use of sequential in here. Then we are set like passing in the activation function. Dropout is there, flattening, as I told you that we are flattening the result of CNN in order to
Hmm.
pass it to the dense layer, right? If
Hmm.
you don't add flatten function in between these two, then you
Hmm.
will also like face errors. Okay, so that is also one thing that people need to be aware of. So all these things, either you need to read up a lot or you need to learn from someone
Hmm.
who can tell you all these things.
Hmm. Yeah.
So that is very crucial in dealing with all these things. Okay, so
Yeah.
I would say that if people want to learn it themselves, then it's fine. If they have time, then they can do it. But people who don't have much time or don't know where to look, then they should look for someone who can teach them.
Mhm. Yeah, first timer, I
Okay.
think first timer, if the person is so obviously they will feel, in which
Yeah.
sequence they have to, move forward. That is
Yeah.
main difficult. Okay.
Yes. Yes.
So in technology part like NumPy, Pandas, Matplotlib. So main concern was in visualization, printing the images in grid view and
Yes.
also displaying the, labels of those images.
Mhm.
That was one good thing. Somebody complete this project, they will learn. Scikit-learn is train test is a normal one, common machine learning task. And other than
Yeah.
TensorFlow, Keras, okay,
Yeah, this is
so
just to create the architecture and
mhm,
compiling the model.
yeah, yeah,
And then again, here in this particular project, what
mhm,
they learn,
mhm,
like the extra thing that people can
mhm,
learn is this reduce LR plateau and early stopping callbacks.
mhm,
Okay.
yeah,
So it will just like if the model is not improving, then you can just set up a callback of early stopping based on your
mhm,
requirement. Like here, the patience was set to 3, you can set to any value like you
mhm,
want. But this is one thing like that comes in handy while
okay,
training the models. Okay.
mhm,
And then reducing LR is also generally what we do is when we are training any deep learning model is that we are setting only one learning rate, either it's going to be 0.001
mhm,
or any arbitrary value. But in this case, what it's going to do is it is going to analyze the trend. Okay.
okay,
So based on the accuracy, let's say if it is not improving, then it will reduce the learning rate itself. And
mhm,
you cannot do it yourself. Like once if you are not making use of this reduce LR on plateau, so your whole model would be trained on one single learning rate.
mhm,
Okay. So this helps to produce optimal results and reduce the time of training,
mhm,
because with the larger the data set, the larger it's going to take, the
mhm,
longer it's going to take to train the model.
mhm,
So this is
okay.
also like two of the important things that in this particular project people can learn.
Hmm. Okay, okay, fine. So we have already talked about the complete project details and what are the
Yes.
different technology we have learned. So last question, like, so based on this project, so what are the different? I think you have already stated
Yeah.
like what are the different things.
Yes.
And so if somebody, so basically this is classification project, right? So using deep
Yes.
learning. So if uh, based on like the input data should be in form of images, based on that any
Yeah.
classification needed. So can you
Yeah,
explain it?
it's just that if you have the data, you can train the model, and this particular model that you have trained
Hmm,
can be utilized in OpenCV. Okay, like
hmm,
computer vision. Using
hmm,
that, you can just create a system in
hmm,
which you can make use of cameras
hmm,
and video feeds, and in
hmm,
that also you can recognize, okay, this is a cat, this is a
hmm,
dog.
hmm,
Okay.
hmm,
So it is a basic, like this is the first step. Once you have the model that you have trained on the images
hmm,
that you
hmm,
want, then you
hmm.
can integrate it into a
Okay.
such a system.
So
Yeah.
Pratibha, so where this type of project at? So can you like give me some real life examples? So where basically, obviously, we have talked about as a developer point of view. So as a businesses, somebody want to implement this type of project. So where they can use in real life. So where like obviously some type of I think this is not camera facing. So maybe object detection directly cannot work. So where this type
Yeah.
of obviously this might be happen like on social media platform or maybe in social media platform different type of images are uploaded, right? So based on that they can categorize the images like which one is good images, bad
Yes.
images, or so like that. So have you some others examples where you can explain this type of uh,
Okay, if I'm particularly talking about classification and not just cat versus
hmm,
dogs. Okay,
hmm,
so in classification there are different kind of things that you can classify.
hmm,
Okay, you can identify the face of a person if you
hmm,
have that kind of data with the label, like the name of the
hmm,
person and the images, and you have
hmm,
trained a model like that.
hmm,
So you can just identify, like if you have a set of images you are collecting from social media, then you can just classify, okay, this picture belongs to that celebrity or
hmm,
that personality. Okay. This kind of thing, so it comes under data analytics in that
hmm,
case. And the same thing, it can also be implemented in researches as well. For example, let's say you have a particular, like if there is a researcher who is working on different kinds of flowers, so just to speed up the process of segregating the data into different categories. Okay, so to automatically categorize the data, this kind of image data, not just any data. So to categorize any kind of image data in any form, it's just that the model should be trained on that kind of data.
Okay.
Okay,
So other
so
than, I
that is
think,
the major purpose.
hmm, so like, yeah, categorization of the images, or like
Yes,
the image classification or data label is the same, or maybe different algorithm is needed.
data label as in,
Like, suppose in this case, only two, like we are assigning, like there is some images without any labels, right? So like 1, 2, 3,
yeah,
4. In that case, you
yeah,
are
yeah.
assigning like cat. This image is for cat. This image is for dog, right? So similarly, there might be, you know any number of, maybe classes may be different, like 10
Yeah,
classes, 20.
classes can be any
Mhm.
number. It's just okay. I understand what you are talking. Like, should it be only binary or multi-class?
No, no,
So
no, no.
in
Yeah,
that,
yeah, that might be. I'm just talking about if there is n number of images, right? And we have to label
yeah,
those images. So just I'm talking about data labeling. So is this project can be used
yeah,
there?
label is important. Label
Mm,
is important
mm,
at first while training the data,
mm,
but sorry, training the model.
mm,
But once you have trained your model and you
mm,
have it,
mm,
then you can make use of it on unlabeled data. But classification is a supervised algorithm, so
mm,
always at the time of training
mm,
you first need to have some kind of data that is labeled. For
mm,
example, let's say even if you want to classify the images of celebrities that you have collected from different sources over
mm,
social media,
mm,
so you cannot just directly pass it to the model and it will tell you. First you
mm,
have to create a database of your own with some of a few of the data that has been already labeled.
mm,
Okay, be it manually. So that is what is the like, this is one of the main drawbacks, you can say, of machine learning, that it is very data dependent. So if you
mm,
don't have the data, you cannot train the model.
mm,
Okay, so first you need to have a database in which you have the images, quite a few number of images from which, like different types of images of one particular syllab. Okay, and like number of syllabs can be many. It's not important. It's just that the number of data should be quite high. It's not like you just selected 10 and
mm,
then you want a greater accuracy. So just for, so like the more the better. This is the
mm,
situation in here. So then if you have that kind of data and then you train your model, after that you can collect your keep collecting same kind of data from different social media platforms, and
mm,
then you don't need to have the label.
mm.
Then
Yeah.
once you have a trained model, you can just pass it to the model and it will tell you, okay, this is this syllab.
Mm,
So that is how it will work
mm. Yeah. So
in
first,
any
maybe.
case, not just syllabs, in any case of data.
Hmm. Yeah, so basically the main point is, based on the images in the form of data, and based on that, first the model
Yeah.
will, learn from the data already available, and then after,
Yes.
then you can test like what these images about. Okay, obviously the any machine learning algorithm, first algorithm will learn from the data, and then based on data, they
Yes.
will
Yes.
either label those images or maybe give the category whatever you want to perform on any images. Okay, okay, fine. So I hope everyone you got some point about these things. I also
Yeah.
I'm not trying to ask too many questions, but what are the question I have in mind. I'm just trying to ask from the Pratibha, and also Pratibha have explained in depth, like what are the at code level. Okay, so then that's why this video is going to a little bit lengthy or maybe larger. Okay, uh,
Yeah.
large in the time. So and also like if we want to learn these projects, or maybe if you have similar project you are working in, right, or any of the person, like we have all talk about like what are the important stages, like data pre-processing part, how displaying the images in this grid view with the labels, and also how designing the architectures, and even we are working similar type of project, either it might be either a student, researcher, machine learning engineers, or maybe developer who are working some company, or maybe even you're a startup, just we are building your own MVP, or any proof of concept you're working, and any of these projects constant we have talked about, any of the artifact you needed for help, so we can help you or assist you. So irrespective of your audience size or whatever, uh, you know learner capability. So we can help to anywhere. Okay, so I hope and also as a somebody want to take training or might be want to uh, take a specialized training deep learning, because I know deep learning is not simple as machine learning, but in deep learning lots of things a little bit extra effort you have to do, doing the same task in spite of instead of machine learning. Okay, so any of these things are facing issue, okay, so you can contact us. We will try to reach out to, first you have to reach out to email or website. Okay, and also you can watch this type of video we are uh, recording. So yeah, and also if this type of video is helpful, so you can also comment down below. We'll try to reach out to us. Okay, uh, yeah, that's all. So if you have anything to say, Pratibha, or I think we have
No,
okay.
I think I've said quite a lot. So yeah.
Mhm,
But yeah, then again, I would just like to mention that even though this video may be very lengthy and you may think that I have discussed things in deep, but it's like I have only touched the tip of the iceberg,
mhm,
and it was simply just an overview. So deep learning is that complex that you'll have to put in quite a lot of time
mhm,
and effort to understand what is
mhm,
happening in each stage and
mhm.
each layer of the whole
Yeah,
project. So
yeah.
yeah, that's it. Just I
Okay,
just wanted to emphasize that.
okay, fine, that's good. Okay, so that's all, everyone. Thank you so much for watching. Let's meet in another one. Till then, keep learning, keep growing. Thank you for watching.